Oh, first, yeah, the first ever. It's really hard to believe. Like when I tell to my friends, I'm going to web conference in Kathmandu, they say, really? There are developers in Kathmandu, but now, oh, I definitely would like to show them this shot. Like, there are some developers in Kathmandu, and it's amazing. Really nice. Yeah, so on the network you can find me as a Pixels Commander, or my email is denis.radin at gmail.com. And when I was 6 years old, my father bought me, oh, I have a clicker. Let me check if it works. Yeah, cool. So when I was 6 years old, my father bought me a PC. It's just like a ZX Spectrum, like Soviet clone of ZX Spectrum, which was loading from magnet tapes. Like, for 3 minutes you should wait, and then some game pop-ups on the screen. It was a built-in basic language, so then it was the time I started to develop. So this was one of the games on this Spectrum PC, and this game was named Manic Miner. So I decided, like, okay, if I'm doing a presentation about mining, then let this guy be on slides about mining in a browser. Oh, yeah, I started to develop being 6 years old, but then I was doing C#, Flash, and then I ended up with JavaScript. Now I work in a company called Evolution Gaming, doing 3D games on the web with WebGL and React. It's really, really nice things are happening there. Sure, can I? Okay, we can skip this. It's really, really nice demo, but I'm not sure how to make it on like a full screen on a Mac. I know, but here,
Can I help?
Yeah.
Mr. President, just a second.
Oh, yeah. You know Russian?
A little bit.
It's just a small thing of what we do, like some special effects. Actually, it's not a simple thing. There is a depth of field effect and some shaders on it. But yeah, this kind of stuff. Yeah, also, I'm very concerned about computer performance, so performance on the web. Like, what are the limits of performing and make quick calculations, high performance calculations in the browser? Oh, there is a reason why I got into that. For 4 years, we were trying to improve performance on the platform on a JavaScript-driven operation system, which is weird, but that happened. Like, there was an operation system, which whole UI was built with JavaScript, with browser, and then there was a C layer, which was connecting JavaScript layer to hardware. So after 4 years doing that, I started to run a workshop on optimizing web applications. And yeah, I'm a fan of optimizations, of performance optimizations. And once, a friend of mine who is like a venture investor came to me and said, hey, Denis, it was exactly when cryptocurrencies were booming. And Bitcoin was $10,000. Said, hey, Denis, we want to mine some cryptocurrency in browser. I know you know a lot about performance. Let's find the most performant way to leverage our users or someone users and mine in the browsers using JavaScript. I said, yes, I can do that. Not because I want to mine cryptocurrency, but because I love performance challenges. So yeah, for me it sounds, hey, want some performance challenge, not like just mine that cryptocurrency. Oh, I took this challenge as a benchmark of what we can do in terms of high performance calculations with JavaScript. Right? So who know how mining works? Okay, then let's explain this. So blockchain. Blockchain is a distributed storage of data. Yeah, and it's created of chains. Like, it consists of blocks. It's a chain of blocks of data, and the blocks contains information. For example, this is a Bitcoin block example. it contains information: who is sending money, who is getting money, and then amount of money transferred. So in addition to this user information, we have also a data to keep blockchain running. It is a hash of a block. Do I have this amazing? It's a hash of a block and a hash of previous block, which basically creates a chain. What is hash? Our hash is a fingerprint of a block. Like if you change even a bit in a block, it's going to have a different fingerprint, so different hash. So this is a string essentially which is unique for every block. And this is important. So yeah, there is a hash of block, hash of previous block, and they create a chain. Like one block have a reference to another, and to another, and to another, but you know, it's a linked list basically. So the network is distributed. Basically every node can put a new block into the chain. And this creates a problem. If there is a one node and only one guy wants to insert a block, there is no problem. But once it's getting crowded and we have a few nodes, then it might have some collisions. To prevent these collisions, there are some mechanisms. And one of them is called proof of work. So proof of work means that you need to make some calculations, to make some work, in order to prove that you put enough efforts into the systems that you can insert a new block, and then it keeps the updates of a chain at the rate administration of a chain wanted. Like for blockchain, it's every 15 minutes. What they do, they track the performance of all miners in the world and make the complexity of a task. Like you need to solve mathematical problem, right, to put a new block. And they pick complexity in the way that the whole stack of machines in the world can solve this task in 15 minutes. Okay, yeah, so you solve the task, you put a block into the chain, and then cryptocurrency, the blockchain of cryptocurrency rewards you with some cryptocurrency for keeping the chain running, because you're essentially making this mechanism live, this proof of work mechanism, and you prevent a network, you prevent a chain from being overcrowded, let's say. Okay, let's get back to a hash. We know that every block have a unique hash, right? So for blockchain, for Bitcoin, sorry, for Bitcoin, the valid block is the one which have 18 zeros in the beginning of a hash. It's a quite unique case. Like you can imagine, it's a random, basically random string, and then the requirement is that the block, they constantly increase the number of zeros. So that's how they control the complexity of a task to solve. So you need to find the block with a hash which have 18 zeros in the beginning. Right, and how this is going to be, they use SHA 256 for hashing. It's well explained and quite transparent algorithm. You can find it on Wikipedia. And the way you iterate through hashes, the way you try to find the right hash, is you change nonce. So nonce is a number you put into hash. There is a field, like a custom field, let's say, in the block, which you can set. So what you do, how mining works, you put 0 into the nonce. So you have from, to, amount, and you have nonce of a 0. You have a cache, you make a hash out of this block, and then you look, do hash have 18 zeros? No. Throw it away, making nonce 1. Having hash of 1, zeros, 18, no. Throwing it away. Then the complexity of finding the right block is like 0 in the power of 20. Oh, I even don't know how this number is called. Oh, a gazillion or... so really, it's really hard to find a right solution. So now nobody mines alone. So miners are being connected into the pools. What pool is? Pool is a server which says, okay, you 10 mine. So you take nonce from 1 to 10, you from 10 to 20, you from 20 to 30, and then everybody is making his piece of job. So once the right nonce is found, then the reward is being distributed with respect to how much you mine, how much calculations you did. So let's consider mining with your users' browsers. Yeah, if you put the mining script and your website or your web application, and let's consider how this can work, how much we can mine from that, and let's consider this also as a performance challenge. So, time for Manic Miner, for having some bitcoins. Should I press this one, right? I don't know. Denis, could you help me? I want my tabs, please. Thank you. So yeah, we have this application, which is interactive mining machine, which allows us to select between different ways of mining. Then we see how many hashes per second we have, and then how many users are using our website or applications right now, and then how many euros a month. So I'm from Amsterdam, then I'm calculating in euros. I see you guys more into dollars, but doesn't matter. So it's approximately the same thing. Right. So how it works? It actually mines with JavaScript, with different kinds of technologies. We will go through all of them. So the first one is JavaScript miner. You just have a script which making SHA 256 from a block, and then we change nonce, and then we see how much we can get from there. It uses a real value of a Bitcoin and a real complexity of mining to show us how much euros we will get in a month. Okay, so now we are mining and 28,000 hashes per second, and it's only one user, so we have 0 euros. And okay, let's consider we have 1,000 users, still 0 euros. Okay, we have now we have nothing. I mean, so if we mine bitcoins with just plain JavaScript, and we have 1 million of users mining, we still have nothing in a month. So, okay, it was disappointment. When I tried that, it was disappointment because it's really hard to mine Bitcoin. So, okay, I decided first, it's fine. Let me switch to the right one. My first assumption was that my hashing algorithm is slow. But then I checked, and actually no. So I was lucky enough, sometimes first time you pick a library which is not the best one, but that was the case. I picked the best library, and yeah, this was a comparison of the tests for different SHA 256 algorithms. Guys, and what is the duration of my talk? How much time do I have?
About 10 minutes.
10 minutes, okay, let's go quick. Okay, yeah, okay, this was the quickest SHA 256 algorithm which is there for JavaScript. So, no. Okay, my assumption was maybe web workers are better because we can do things in parallel. So I made a web workers miner, which mines in parallel with many web worker miner. Let's go. Oh, we still have 1 million here. Should be not like that. It's probably the feature of operation system. To keep them. Okay, let's go. Okay, web worker. Oh, it was 28,000 hashes. Now it's 70,000 hashes, which is quite an improvement. So we have few web workers mining in parallel. So we use few cores of this laptop. By the way, yeah, I found nice thing when doing that. If you never made hard tasks on web workers, it might be also a new thing for you. So there is a navigation dot concurrency in a JavaScript, window navigator concurrency, which tells you how many cores are available now for doing some job. So I'm using this to check how many cores I can use for mining. Right, so, oh sorry, I stopped it, but still let's check how much money is that. Actually it's still nothing. It's 3 times more of nothing. So it was 0.1, now 0.3. Okay, I'm not the guy who really says after the second try, I'm tired. No, I went further. How about WebAssembly? Oh, WebAssembly is a thing which allows to evaluate, to execute C++ or Rust or other languages, transpiles them to something like bytecode for JavaScript. So, and the promise of WebAssembly is that it's nearly native performance there. So, time for Manic Miner. And we have WebAssembly Miner. Let's keep it like that, with 1 million. Yeah, okay, it's way faster than JavaScript. I think if I do it in parallel, if I use web workers in combination with WebAssembly, I maybe can have 200,000 hashes. And it's still like 20 times of nothing. So, but still, it was another disappointment, but I went further. Right, the next way. I heard that mining on GPU using a video card is what is really people are using for mining. Like people are buying a lot of video cards. You've heard that, and then many places video cards got that expensive that basically gamers were not able to buy them. So, okay, it happens, why it's so efficient, because in CPU you can mine in 3 threads, on 4 threads, like what's available for JavaScript, for 4 cores. But GPU mines in many threads. Like GTX 960 mines in 1,600 threads. So, yeah, like 1,600 calculation at the same time, and it's very efficient because it mines on hardware, and it's specially designed for these mathematical operations. And in WebGL we can mine with pixel shaders. So how it works? So pixel shader, what is pixel shader? Pixel shader is a program which can calculate the color of every pixel on the screen, and then it's written in a special language called GLSL, OpenGL shading language, and it's working blazingly fast. So for us as a web developers, what's important is that the interface, how we can communicate with pixel shaders, is a canvas. So you create a canvas with WebGL, and then on WebGL on canvas you can run shader. It's to say it's simple, actually it's a bit more complicated, but you can make it with canvas and a WebGL context. So how mining with WebGL and GLSL works? So you have a shader which is being executed for every pixel. Yeah, that's a canvas of 4 by 7 pixels. So this canvas can be drawn in one go with a GPU. For every pixel we run a pixel shader, which knows, okay, this pixel says our first nonce is 435, right? And the next pixel is going, and I'm going to calculate color for 435. And this one calculates the color for 436. Then next, they know coordinates. So they know each other coordinates, and they know the starting nonce. So it's done in parallel. And if you create a canvas big enough, like 1,000 by 1,000, you can calculate 1 million of pixels, 1 million of nonsense in one go. So let's try to do that. Time for Manic Miner. And how it responds to Miner. Okay, we do the shader. If one of pixels, and the shader says, okay, if nonce is incorrect, if block is invalid, I keep pixel black. But if nonce is correct, and we mind, and we will get a revert, I make a pixel, some particular color. For example, black or green. Like, it doesn't matter. It's just how you code it. I'm not sure. Maybe there is no WebGL on this PC. Maybe it's not supported on the system because it's not mine PC. All right, I can tell you what's happening. Like, it's going to be around JavaScript speed. Oh, I'm not going to connect another one. So the problem is that even if calculating this nonsense is very fast, but then to check color, you know, who worked with canvas on JavaScript? Canvas element. Okay, few people worked. So the only way you can read the color from canvas is to get a color is array of arrays, basically a 2D matrix, and then with JavaScript iterates through every pixel and check what is the color of a pixel, and then so it involves a lot of JavaScript, and JavaScript is slow, very slow, comparable to GLSL. So I said, okay, maybe we can do some optimization. For example, if we calculate not one single nonce in a pixel, but we can calculate 1,000 in here. We calculate 1,000 of nonce for every pixel, and then it means that we need to read 1,000 less for the same result, right? So sure, maybe only this one is broken. Let's see what this optimization brings. Oh, this one is now both Java, WebGL miners are broken on this on Unix. On Mac it works, on Windows it works. Yeah, so here it was a really huge improvement. So with WebGL, with this optimization, it was approximately 200 times more performant. Like in the beginning we had 27,000 of hashes per second, and then WebGL with optimization gives like 6 millions of hashes per second, which is a real improvement. And it's like you're starting getting some sense there, but it's still only some bytes. So why it happens? Why mining Bitcoin with for 1 million users? Yeah, so it's reading textures. Yeah, what the hell? Why it's so less money? Oh, even we had 200x improvement, but still no money. And then the problem is the evolution of mining tooling. So initially there was a CPU era when people were just mining on CPUs, and it was okay, but then there was the progress of having GPUs, right? And GPUs have calculation power as high as 1,600 CPUs, which is good. So we proved with the JavaScript, I proved with JavaScript and WebGL that GPU can mine way quicker than CPU. So there was a mining tooling for like hardcore miners. GPUs. They were buying a lot of GPUs, putting them into farms, and having a profit. But then some clever people decided, okay, why should we mine with some expensive devices and some very universal devices? Because for these GPUs you can play games, and on the other hand you can mine things. So let's invent a special chip, like a very simple chip, which only thing it can do is mining. So ASICs are very efficient in minings, and if GPU is like 1,000 CPUs, then ASIC is like 20,000 of GPUs, which is like crazy. So now these people compete with each other, and using GPU you can compete with them mining Bitcoin. So only with ASIC you can make some money. And of course ASICs are not something you can do with JavaScript, because it's a hardware, it's not a software. Yeah, like the mining of Bitcoin on the web is definitely broken. So the new generation of cryptocurrencies actually fixes this, because what they do, they try to make it ASIC proof. Oh, the algorithm of a new cryptocurrencies like Ethereum and many others are made in the way you can't build ASICs for them. Oh, and I try to mine Ethereum on the web, and actually the problem with Ethereum, it requires 3 GB of RAM. And web is not able to do that. Like 3 GB of RAM, you are not being able to allocate, not for JavaScript nor for WebGL. So web is failing here. Are there any alternatives? So actually there are. There is XMR Monero, which is very efficient to mine on CPU. And you can mine it also with WebAssembly. It's quite well doing cryptocurrency, which is good in many ways. First of all, it's very secure in terms of anonymization of transactions. So currently, FBI can decode Bitcoin transactions, but for XMR Monero, they recently started a contest who can hack Monero and give us some knowledge from that. And yeah, let's see what we can mine with XMR Monero. Oh, it's still, no, it's actually mines, but, oh, it runs. It's WebGL sync mining. You just needed some time probably to start. Yes. Right, let's go for Monero. Whoa. Whoa. It's quite some money. Oh, it's real data. It's like a real value of Monero. And yeah, how much you can get if you have 1 million of these laptops mining 24 hours a day for you. Like if you have 1 million of users with such laptops and then mine. Yeah, let's say you have, yeah, because algorithm is different. For Monero, algorithm is completely different, so we are not interested in hashes anymore. We've been comparing Bitcoin's algorithm and ways we can calculate Bitcoin hashes, but now it's a different hash, so only 32. So even you have 1,000 users who are constantly sitting on your website, like, I'm not sure, long reads. Like if you have an application with long reads and people read your content, that's the money you can get from 1,000 users. So essentially, with this kind of laptops, it's like €1.5 a month from constantly sitting user. Of course, people are not doing it 24 hours a day, so it is more complicated to calculate. But then this is money you can live on even in Europe. Right. So, yeah, a good thing to know about the Monero that there are some services which allow you to put a plugin on your website, so you are not. It's not required for you to create some code by yourself or some solution for mining. So CoinHive is one of them. Yeah, this thing is really nice and very easy to use. So what they do, they ask you to put a script on the website. Here you see it's a script, CoinHive, and then I'll make it bigger. And then you create a miner and say just miner start. How many minutes is that? Oh, done. I'm just saying just how to mine, and I'm done. So you say miner start, and you start. But there are some options. You can set how much eager you want to be as for user resources. You can say like, I want to mine using 50% of user resources, or 100%, but then this guy will blame you for sure. Oh, then yeah, I would keep it like 30%. And I would definitely, there is a big problem of ethics behind that. You are mining using user resources. Now, there are a few more implementations. CoinImp doesn't have any commission. And there is a crypto noder which is open source, so you can create your system like CoinImp or CoinHive. So they have miner and a pool open source. So, yeah, like now some kinds of advertisement, personalized advertisement are being banned, and this might be a replacement for advertisement. Like, why not mining instead of showing some ugly ads? And the ethics behind that, you should always show a warning, like we are going to mine with your laptop or your machine, and then are you going to support us? If you love our resource, please mine a bit with this website and give us some money to keep running. So this is going to be ethical. But if you're just going to make it silently, I think it's not the way to proceed. So yeah, anyway, mining in the browser is a reality. You can do that. You can do some money with that. But I also hope that you were not just about being impressed, but then you see how different technologies rely and how different technologies allows us to operate in a browser in terms how big the difference is between mining with a simple plain JavaScript and mining with a WebGL of 200 times. So yeah, it's quite powerful platform, and we can use it for many good things. So let's proceed with it. Cheers, guys. Thank you for having me.